Hello everyone, my name is Hisham. I'm the owner of Clemson Aeronautics, where we make the riveting and dimpling tools. In this video, we will be discussing the operation of the CAD1 system, the machine that dimples. That's the competitor of the DRDD2. And it's the same thing if you buy our conversion kit and put it in DRDD2, it will be the same setup. Now we installed the mechanism in the front of the machine, and we aligned it directly perpendicular using that edge, like we said in the last video, with a square. And this is where we at right now. So initially we just put our squeezer on, and the pin is in there, and the die is also in there. Now, the machine is very versatile, and I left this pin long enough so you can reach as deep as you want to with the pin almost all the way in. That helps it with the direction. And we need to discuss one thing here that is important, which is, what if I want the pin to sit a little higher than what it is? You screwed it all the way in and you still don't have enough gap over here, because like I have this pin all the way in. When I pull the trigger, it comes down. It's not clamping. There is just a little bit of play here. So as soon as I move this, it will be tight. What if you want to create more gap? There is a couple of things. The first thing, you probably want to cut the pin, but the problem with that, once you cut the top of the pin, let's say this is the pin that holds the die, and you just wanted to take about 100,000ths off or a quarter of an inch off or something like that, with just a cut-off wheel on a grinder, and you can just cut it off and deburr it, and it will work just fine. I like to leave as much as I can inside the RAM over here. But so what other solutions do we have? We can come up with this a little bit. This is compressed. So what we can do is we can push this down. Have you seen this tool before? It's a little pointy thing that you can get, and you help it, with the when you're drilling out a rivet or something, but you can get anything pointy. And this, the ram, the adjustable ram on the squeezer itself, you can turn it with one of those pointy things that easy. And if it doesn't, you can just open it up and screw it in a little bit. But we will do that right here, like this. Now, I adjusted the machine when there is a gap. You're going to tell me, well, it still didn't come up. Of course, you have to do these two nuts to let the ram, the springs, push the ram up a little bit. So now you can get away from it. So the other thing that you can do, there is this bolt right here that holds this piece to the ram, have a nut underneath it, and the whole purpose is, if I want to get a little closer up, I can remove this nut and put that bolt on here without the nut. I can replace it with just a couple of thin washers if I want to. That will work too. So it is very versatile. You just undo these nuts down here and let the ram up a little bit. So this is where we're at, and we want to line it up right here. So what I'm going to do, this have Allen screw underneath, so I'm going to use that, and I can do that here. I'm going to pull the trigger, and I'm going to make sure that they're lined up fairly decent. And I'm going to unscrew this pin. Okay, folks, let me switch hands. This pin, I will unscrew it so it would come out of the ram till it's tight. And I'm holding it down till it's tight. So I'm holding it in place. Now they are lined up perfectly. I'm gonna look underneath, and I'm gonna go screw this, screw in, tighten it up. So now, every time I pull the trigger, those two touch, the dice touch. No movement here. You're not putting any pressure on there so far. So, how am I going to create pressure? It's according to the thickness of the skin that I have. In this case, for the demonstration, this skin used to be the horizontal stabilizer skin. So it's 25,000. It's thick, not like the other skins that's 16,000. So it needs a little bit more pressure. So I need to put at least about a turn and a half from touching. So I did this, and they are touching now, so I want it to go a turn and a half. So I am going to make a mark which on the nut right here. On this flat, I made a mark, and I'll screw it a turn and a half. So here is 1 and a half. So that made the pin extend out a turn and a half. So I'm gonna hold the pin, and I'm going to tighten the nut now. And I'm gonna get my wrench. A little snug. Now every time I pull the trigger, you're gonna see the head comes up. That means it's applying pressure. And now when I put the skin in, it's gonna go 25,000 thicker material. It means that it's going to go up another 25,000. So the turn and a half, how tight is that? This thread is half 13 thread. That means there is 13 threads per inch. To round it up, every turn translate to 70,000 extension from the screw. So I made it and a half, so it's 105, 110, something like that, that I had extended it. So I'm applying a lot of pressure from my CAD1 system onto that skin. Now that we have set it and bolted everything down, another thing to mention, now you guys know that I have a table, and the cart for the machine, and it is so easy. So if there is a big part in here, I can move the cart back and forth and leave the entire skin up here. So it will be more convenient. I'll bring the tables away from the wall and I can just move the machine and then slide the work this way. There is another issue that I would like to talk to you guys about that, and this is kind of an advice also, and I mentioned that in other videos while I was building the airplane. Right now we're dimpling for a number 3 rivet. So the diameter of the hole for a number 3 rivet to begin with, without final drilling it, is 0.093 and some change. Let's say and a half. All advanced instruction, when they say a number 3 rivet, you have to, match drill it to number 40 drill, which is 0.098. Now you have to understand, when you dimple any skin, the hole will get bigger. So what's the diameter of the rivet to begin with? Is 3/32, which is 0.093, let's say 5. So if you start with this hole, 0.098, then dimple it, that hole is going to grow to 0.107, 0.108, something like that. It becomes huge. And the rivet itself doesn't have enough meat to expand that much, which turns out to be really weak shop head. So what I did in my airplane, which worked out very well, is use a reamer. It's a little tiny reamer, and I'm sure you can buy one yourself, and there's a lot of my friends and customers that did that, followed me on that, and they did very well. This is just a tiny little reamer. I got mine, it's a solid carbide one. It ought to last me the entire build, because all what I'm using it for in aluminum, and this is carbide, you ain't gonna dull that out. So this is what I'm going to use to match drill these holes. So the holes has been drilled to 3/32, and now I'm gonna match drill them to 0.095. Okay, folks, I already match drilled with the 0.95 reamer using my cordless drill. There is something that I would like to make clear to everybody that's watching this video, because I think a lot of people are misinformed. You get into a forum on the internet, and they're all racing to buy the pneumatic drills. They don't know what they're doing, really. In reality, they don't know what they want a drill that goes 4,000 RPM and uses air for power, and after you use it 5 or 10 minutes, the compressor cuts on and runs till it compresses the air again. You need a huge compressor to do that. The amount of energy that you use to compress that much air just one time is enough to charge this drill that would last you a day or two. That's one thing. The other thing that most people don't know is that you really don't want to go at 4,000 RPM. And I'm gonna, in a video that's coming up soon, it will be instructional video doing the practice kit, like the flight control practice kit from Vans. I'm gonna go through that, and I'm gonna talk about this. Don't waste your money on an air drill. You pay 5 times as much as this drill. Then after you do it, you pay 100 times as much in energy to run it. You don't need it. So I use my trusted Harbor Freight Bauer drill that I dropped from 8 feet high on the concrete twice before, and it still works. 5 years old, and it works great. I match drill the parts that we are going to dimple right now, and we're going to start dimpling. The male die goes on the bottom and the female goes on the top. So if there is any of the just very fine dust, aluminum dust there, it doesn't pack up in the hole. That's the very important thing. Besides, when you put it in the hole and you hold it down, it holds it into place, so you don't get one of those figure-8 holes in your aircraft skin or whatever it is that you're dimpling. So put it on there. That's the first hole. So what we're gonna do is we're gonna put a rivet in there and check it out. And whoop, it looks pretty good. Actually, it's very flush. So the first hole is good. We're gonna continue with our dimpling. One of the things that I like to check the size of the hole now. It is 101.5. That is very, very good, very acceptable. If you have started with 0.098, this would have been much larger, like 108 or something like that. So you want to be careful with that. And the plan is to have the two tables like that, and you level them off together with the die. Like I set it up before I started, where this die, I used this wood before I put the die in, but this is perfect right here. So we are going to continue with our dimpling now, and it's as good as that. That is those that we wanted to do, which is the number 3 dimples, and then we're going to finish the other piece. The other piece I'm saving for the card 1 demonstration. This is the CAD one. The card one is over there. I'm going to do the setup and demonstration for the riveting on that. So I'm going to go ahead and dimple that on the card 1. And now I just exchanged the dies for the number 4 rivet, the dimple for number 4, And these holes are drilled for and match drilled for exactly 0.125. So we're gonna go ahead and dimple those as well because it's a part of the demonstration for the CAD1. And here we go. And let's get a rivet and check it out. And that is the number 4 rivet, and it feels very flush. It's just a perfect dimple. The only problem with it is, of course, I cannot do anything with the die. When you start with like 0.125, which is 1/8, by the time you dimple it, the hole is about 140 thousandths. So the hole gets a lot thicker, but I cannot do anything about that. And so this is what we're going with. So now I have dimpled all the number 4 rivet dimples as well. And this concludes the dimpling demonstration for the CAD1 system. Well, folks, I hope you learned something from this demonstration. As far as the folks that got their machines lately, if I did not answer any question, because what I'm doing here is I'm asking myself your questions or the things that I think you will be asking me and answering them on this video. And I don't know what else you could be thinking of or problems you could be going through. So I'm always open to video calls, guys, and I do that all the time. And people just cut through the chase. They want to know something so they can get back to work. They just don't want to waste a lot of time. They send me a message, something, let's do a video call. Okay, no problem, we'll do a video call and I can see what he's looking at. And I can explain to him. So as you can tell, the machine is very versatile. You can change a lot of settings here and there and inside here and here, everywhere. And as far as using the machine, leaving the work on the table, I advise you, all you guys that got the machines, whether it's the CAD1 or the CAD1 or the conversion kits, there's a lot of you now out there. I strongly recommend building a cart for your machine. And you're gonna have this setup for your work on 2 tables with the opening in between like that. And you can move the machine back and forth and leave your work on the table flat so you can get it perfectly perpendicular. Use something straight to just adjust it to get your level here on the bottom of the die. I was a little bit too low. I wish that when I started doing this demonstration, the machine was a little bit higher, maybe about 50 thousandths or so, or maybe 75 thousandths, a little higher. I could tell it was open, and I just wanted to finish the video because it's been a long day already. So that's it. If you have any questions, give me a call and let's do a video call and address any issues that you don't know. The other thing, you guys don't forget, don't waste $250 on that pneumatic drill that you're going to spend a fortune trying to run for absolutely no reason whatsoever. So you would know inside the maintenance hangar, there is fuel in airplanes and all that stuff. So OSHA and those guys and companies don't want electric drills inside just in case of the fume, it will catch fire and stuff like that. That is the One and only reason. As far as RPM concerned, I am going to show you where inside Van's aircraft, a gentleman using a cordless drill and using it very slow. You can almost count the turns while he's using it, okay? Drilling, you don't need to go fast, especially in aluminum. The faster you go, the worse you're gonna get the hole, because remember, going in and going out, the side of the drill itself is gonna be eating the hole. So instead of eating the hole at 4,000 RPM and just really muck it up, do it really slow, going in and going out. That's the secret for drilling. You don't want to mess up the holes on your skin or your spars or your ribs. So this is my 2 cents worth. It's about $1 worth today. I'm sorry it took so long, because I am not a filmmaker, and I mentioned that before. I'm not a salesperson, and I'm not a filmmaker. I'm a tool maker. And for me to explain how it works, I need to take my time, and I hope you guys are not bored about how slow I'm going. I had a few of my customers come here to pick up their machines. And believe it or not, most of them says, we like the way you talk slow. I want you to slow down so I can understand what I'm talking about, what you're talking about, because this is something I know nothing about. If you have any questions, there is many ways you find out the answer. One of the easiest ways to find the answer is to a question that you have is write it in the comments of the video. So when I answer it, not only you know what the answer is, everybody else that watched the video. That's one thing. The other thing, you can call me. If for some reason I don't answer because your number showed up as scam or scam likely, just leave me a message and I'll call you back, and then text me. Say, I am John, please give me a call. I need to ask you a few things, and most likely I'll call you right away or just as soon as I finish what I'm doing. Folks, thanks a lot for your support and all the people that bought machines. And thank you for supporting our business. Please don't forget to put a like, and if you had not subscribed to the channel, let me advise you, subscribe to the channel, because you never know when I'm gonna do a sale, and the sale is always advertised on my channel with a fresh video, so you'll be notified and you'll see there is a sale, so you can buy whatever it is that's on sale if you like it or if you need it. Thank you very much for watching. I will see you next time.